So this first one is saying, find the value of x guaranteed by Rolle's theorem for that function on that interval. So first you have to make sure that all the conditions are met. And Rolle was this picky guy. There were 3 conditions for his theorem. Function has to be continuous, differentiable, and start where it ends. If those things aren't true, then we just don't do the problem. And occasionally that happens where they'll say on the AP exam, you know, either answer this question or explain why you can't. And not meeting the conditions would be why you can't. So you always have to check them. So first of all, is the function continuous? Well, this is a parabola, so yes. And is the function differentiable? Well, again, yeah, a parabola doesn't have any sharp edges or holes or breaks or vertical tangent lines, so that's good. And then the last condition is it has to start where it ends on this interval. So we're going to plug in -1 and +1. And it doesn't matter what they come out to, but they have to be the same. You know, they could both come out to 5,000, it doesn't matter, but they have to be the same number. So if we plug in -1, -1 squared is 1, 1 minus 1 is 0. And if I plug in +1, same thing is going to happen. I'm going to get 1 minus 1, which is 0. So we have all 3 conditions met, and so that means we can do the problem. So again, what Rolle's theorem says is if you start and end at the same place, then you must have turned around. And so you're going to end up with a horizontal tangent line. So it is derivative equals 0. So hey guys, what is the derivative of this function? Yeah, good, cool, thanks guys. -2x, the 1 is a constant, so that's going to be gone. Nice job remembering to keep the negative in there. So we're going to set that equal to 0. Cool, good job. And then divide over the -2 and you get 0. Now before you decide that that's your answer, and if you're thinking that's it, yep, that's it. That's all. You set the derivative equal to 0, solve it. But before you verify that that's your answer and say, yeah, this is my final answer, make sure it's on the interval, because sometimes it's not, and then you have to get rid of it. But 0 is on this interval, so we are going to keep it. And so that's your answer. All right, so number 2, find the value of x guaranteed by mean value theorem for ln of x on this interval. So this has 2 conditions. Function has to be continuous and differentiable. Now ln of x does have an asymptote, and it is at x equals 0. This is ln of x. It looks like a sideways swoopy kind of thing. So yes, there is an asymptote, but this is the interval that we're talking about. So we're only looking from 1, which would be right here, until e squared, which I don't know what that is off the top of my head, but I know e is 2.7-ish. So if I square that, it's going to be, bigger than 1, something kind of over here. Like, let's say that's right here. And this portion of the graph is what we're looking at. So just from there to there. Let me color code that. So just this portion is what we're looking at. So yes, there's an asymptote, but it's not on this interval. So for this portion, the function is continuous and also differentiable. So both of the conditions are met for that interval. So once you decide, hey, you can actually do the problem, then you have to remember what mean value theorem means. So mean means average. We're going to do average rate of change equals instantaneous rate of change. So average rate of change means slope. So we're going to do slope. And then instantaneous rate of change means derivative. So we're going to get the slope, we're going to get the derivative, and we're going to set them equal to each other. So to do a slope, you need 2 points. So we're going to need 1 comma something and e squared comma something to get a slope. And so we're going to take those and just plug them into the function. So hey guys, what is ln of 1 without a calculator? Because that is something you would need to know. ln of 1, what is that going to give us? Good, nice, 0. ln of 1 is 0, perfect. And then what would be ln of e squared if we plug in that one? ln e squared. I know this one's throwing you guys off a little bit. Good, 2. The ln and the e are going to cancel, and so it would just be 2. So ln e squared, the ln and the e cancel out, you'll just get 2. All right, so those are our 2 points, and we're going to use them to do the slope. So it will be 2 minus 0 over e squared minus 1. So that is our slope. So we did that. All right, now we need the derivative. So derivative of ln of x is 1 over x. So this is our slope, this is our derivative. We are just going to set them equal and solve that. And so what I'm going to do is cross multiply. Also, since this is minus 0, we can, basically ignore that. So when I cross multiply, I'm going to get 2x equals e squared minus 1. 1 times anything is not going to change it. Like distributing a 1 through here, it's still going to be e squared minus 1. And then last step to get x by itself is we're just going to divide by 2. Now, you do need to make sure that that is on the interval. I know this is really tough because without a calculator, you're like, well, I don't know exactly what that is. But if this is e squared and this is 1, if you subtract those and divide by 2, it's going to end up being in between, because essentially what you've done is just average them. And it's mean value theorem, so that's what you end up with. All right, number 3. If our function is this, show that. All right, this is going to involve some writing. You're going to have to do an explanation. It's going to be a sentence, right? Show that there is a value c on the interval 0 to 3 such that f of c equals 10. It doesn't come right out and tell you what theorem, but this is going to be intermediate value theorem. We're going to have to show that 10 is in between the 2 other values. So what we're going to do is plug in 0 and plug in 3 and show that 10 is in between them. And it's going to just be a sentence that we have to write. But first we have to plug these in and see what we get. So if we plug in 0 for x, we're just going to get 0. And if we plug in 3, all right, 3 cubed is 27. 3 squared is 9. So 27 minus 9, that would be 18. Plus 3 would be 21. And so the whole point is, yes, 10 is in between those. But like I said, you have to mention the condition of the theorem. We're going to use intermediate value theorem. You have to mention that the function is continuous or they won't give you the points. All right, so you have to say that in your sentence somehow. All right, so we are going to say, since f of x is continuous, and it's a polynomial, a cubic function is going to just, wiggle. That's going to be continuous. There aren't any, asymptotes or poles or anything in that. So since f of x is continuous on 0 to 3, and now here, you can word this however you want. You have to say in some capacity that 10 is between these other 2 values. So here's what I think is the quickest way to say it. F of 0 is less than 10 is less than f of 3. That's the most succinct way to put it. But some people don't like the math notation and they want to write it out like in words. Like if you're more an English person than a math person, you can say 10 is between f of 0 and f of 3. It's a little bit more writing, but you can write it out in words. Yeah, knowing to use the intermediate value theorem comes from practice. You know, they aren't going to tell you. But typically when it says show that or justify that there is an output value, it's going to have to be intermediate value theorem. If they want you to justify that you have some sort of output, that's the theorem that tells you that. If there is an output, then it had to have come from somewhere. So if that's what they're asking you to do, it's going to be intermediate value theorem. But yeah, you're right. They don't mention it. Yeah, I'm totally on your side with that. They don't say what theorem you're supposed to use. You got to come up with it on your own. All right, so since the function is continuous on this interval, and this is all true, then, and here's where you get to throw their own words back at them. They wanted you to show that there is a value c on this interval such that f of c equals 10. You're just going to repeat that. Like, I know it's a little bit of writing, but just say that again. Since all this is true, then there is a value c. I'm not joking. On the AP exam, you can do this. Just recopy the question. There's a value c on 0 to 3 such that f of c equals 10. So I literally just rewrote what they had. That's what they asked me to prove, so that's what I'm going to say. And then you want to say what theorem you used. So by intermediate value theorem, and you are totally allowed to abbreviate that. They accept the abbreviations. So it's intermediate value theorem. Let me recap that because I know writing a sentence is kind of a lot. We had to mention continuity. That's a condition for the theorem. So since the function is continuous on the interval, and 10 is in between these other two values, then I just recopied what they put. Then all of that is true. And then this is the theorem that we use. But yeah, usually if they're asking you to justify something, it's going to either be intermediate value theorem or mean value theorem. It would typically be one or the other of those. And this one was asking you to show that there was an output. So that's how we know it's this one. All right, so number 4, find the value of x guaranteed by Rolle's theorem for this function on 0 to 3. All right, so there are 3 conditions that have to be met. So is the function continuous? And this is polynomial, it's a cubic function, so yes. And it has to be differentiable, which again, all polynomials are nice smooth curves, so yes. And then for Rolle's theorem, it has to start and end at the same place. So I'm going to plug in 0 and plug in 3. And it does not matter what they come out to. They just have to come out to the same thing. So that whatever number we get, it does not matter. It just has to be the same. It has to start where it ends. So if we plug in 0, we're going to get 2. And if we plug in 3, so 3 cubed is 27. 3 squared is 9, times 3 would be 27. So 27 minus 27, that's gone. And then plus 2, so we get 2. And so that third condition is met as well. All right, so if your function starts where it ends, it has to have turned around. And so its derivative equals 0. If it turned around, you're going to get that horizontal tangent line. All right, and so this derivative would be 3x squared minus 6x. 2 is a constant, so that's gone. Equals 0. And then we're going to factor. So we can factor out a 3x, so GCF, and we're going to be left with x minus 2. And so we're going to set each of those equal to 0. So 3x equals 0. That's just going to give you 0. And then this one's going to give you 2. Now, one of them is our answer, and one of them we have to dismiss. So guys, which one do I have to get rid of? Because one of them is not an acceptable answer. Good. I'm going to have to get rid of 0. And I get to keep 2. How come I have to get rid of 0? What's the matter with 0? Yeah, good, perfect. 0 is an endpoint. And so I cannot include that, but 2 is on the is within the interval, so 2 we get to keep. All right, and then this last one is mean value theorem. I'm gonna get you started, and then what I'm gonna do is just pause. I want you guys to try this one, and then I'll go over it. All right, so mean value theorem, there are 2 conditions. Function has to be continuous, which this is a parabola, so it will be, and differentiable, which again, a parabola is going to be differentiable. And then mean value theorem. Mean means average. What you want to find is an average rate of change and set it equal to an instantaneous rate of change. So it's going to be slope equals derivative. So I'm going to pause. I want you guys to just take a couple of minutes and try it, and then I'll go over it so that you can, check your work. So even if you don't have this printed, just try it in like your math notebook, scrap piece of paper, and then I will go over it. So just take a couple minutes and try that, please, guys. All right, let me go ahead and go over this one, and you guys can check your work. So to get a slope, we're going to need 2 points. And so I'm going to plug in the 0 and the 4. So if we plug in 0, we're going to get -3. And if we plug in 4, let's see, 4 squared will be 16. Double that will be 32. And then -3 will be 29. So those are your 2 points, and we're going to get the slope. So 29 plus 3 over 4 minus 0. So that is going to be 32 over 4, which is 8. So our slope is 8. And so we're going to get our derivative and set it equal to 8. So derivative of this function would be 4x. And so this is our instantaneous rate of change. This is our average rate of change. I'm just going to set those equal. And then when I divide by 4, I get x is 2. And then lastly, you just want to double check that that is on the interval, and 2 is within that interval, 0 and 4. So we're going to keep that as our answer.